Welcome back to the discussion and thank you for always joining us. We are presenting a question that was done in K.c.s.e 1989 paper 2 question number 19, a question on angle properties of a circle. And the question we have reads, in the figure below, O is the center of the circle, PQ and PR are tangents, angle PQS is 40 degrees, and angle PRS is 30 degrees. We are going to start off by considering OQ, which is the radius of the circle, and the QP, which is the tangent. Remember, the radius and the tangent will form 90 degrees. We already have 40, meaning we are going to have 50 degrees at this point. And if this is 50 degrees, we are also going to have OR as the radius. Already we have 30. The angle at this point is going to be 60 degrees. Once we have that angle, we can proceed. We are going first to drop a line downwards from R to Q, such that we are going to have the angle at this point, which is 40. We are also going to have 40 degrees at this point. And if that is the case, the angle at this point will be 20, meaning here is also 20. And if the whole angle was 50 degrees and this is 20, the remaining angle here will be 30 degrees. And if that is 30 degrees, we are going to have 20 plus 20, which is 40. From 180, this one is going to be 140 degrees. If this is 140, the angle subtended by QR at the center, which is 140, that chord will subtend an angle of 70 degrees at the circumference. Once we have done that again, we can be able to get the whole of this angle here by taking 360 minus 140. This one is going to give us 120 degrees. That means the angle outside here will be 120 degrees. And if this angle is 120, then we are going to have the angle at this point, which is going to be obtained by simply taking 40 plus 30, which is 70. This angle is going to be 110 degrees. And if that is the case, then we are going to extract this triangle here. This is P, this is R, and this is Q here. We know this is the whole of this angle here is 70 degrees. And also the whole of this angle here is going to be 70 degrees, meaning 70 plus 70 is 140. We are going to have 40 degrees at this particular point. So we can begin from Roman 1 by having the size of angle RTQ, and the angle RTQ is going to be 70 degrees. We move to Roman 2, and in Roman 2 we need ORQ, and ORQ is going to be the angle at this point, which is 20 degrees. Then lastly, Roman 3, we are going to have ORQ, and OR, that is ORQ, is also going to be, that is ORQ is 20 degrees, and lastly Roman 3 we have RPQ. This is the angle at the point P here, which is 40 degrees. So RPQ will be equivalent to 40 degrees, and that gives us the answer to this particular question. Next, we look at K.c.s.e 2001, paper 1, question number 20. And the question we have reads, in the figure below, points O and P are centers of intersecting circles ABD and BCD respectively. Line ABE is the tangent to the circle BCQ at B. Angle BCD is 42 degrees. Stating reasons, determine the sizes of angle CBD, reflex BOD, and show that triangle ABD is isosceles. Already, we know that a point D, a point O, B, and C form the 4 points on the circle, giving us a cyclic quadrilateral. And remember, the opposite angles of a cyclic quadrilateral add up to 180 degrees. And if this is 42 degrees at this point, then the angle at this point is going to be 180 minus 42 degrees, giving us 138 degrees. If that is what we have again, we can get the angle at this point here, and the angle at this point, which is going to be the angle BOD, would be equal to 360 degrees minus 138. This one gives us 222 degrees. The reason we can give here is that angles at a point add up to 360 degrees. Once we have done that, we can now move and get the missing angle, which is CBD. To get CBD, we are going first to take OB as the diameter of the bigger circle. Then from a point P to B, we are going to have 90 degrees at this point. And also, we are also going to have 90 at this particular point here. We know for sure that if this angle is 138 degrees, we can get the angle at a point A by taking 138 divided by 2, giving us 69. So this is 69 degrees. And if that is the case, we have also been told that triangle ABD is isosceles, meaning if we assume that AD is equal to BD, which is going to be equal to, that is, we can assume that the angle A, that is D, we can assume that angle DAB is equal to angle ADB. That means if this is 69 here, we are going to have 69 at this point, meaning to get the angle at this point, we are going to have 169. We are going to have 69 times 2, which is 138. That means 180 minus 138. We are going to have 42 degrees at this point. If that is the case, to get the angle, which is Roman 2, angle, that is Roman 1, which is angle CBD, angle CBD is going to be equal to CBD will be equivalent to we are going to have 180, which is angles on a straight line. Then we minus, we have 90 plus 42. This one is going to be 180 minus 90 plus 42 will give us 132. And this one is going to give us 48 degrees, which is the angle at this point here. Once we have done that, we can now be able to get the size of that angle, and the size of the angle in question is going to be 48 degrees. Reason we can give here is that angles on a straight line add up to 180 degrees. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.